electric cells can be connected either in series or parallel. In this video, I am going to explain cells in series. When a number of electric cells are connected in series, total EMF of the battery is N times psi. Psi is the EMF of one cell. When you are connecting in series, negative of the first cell will be connected to the positive of the second cell. Then negative of the second cell will be connected to the positive of the third cell, and so on. And the positive of the first cell and the negative of the last cell is the positive terminal and negative terminal of the battery. Now when cells are connected, it is called battery. Now this is the positive terminal of the battery and this is the negative terminal of the battery that is connected across a resistance. Then total EMF of the battery is N times psi, where psi is the EMF of the single cell. In this example, 4 cells are connected in series. Now total EMF of the battery is N times psi. Total resistance in the circuit. Each cell there is an internal resistance. Internal resistance is represented by small r. So then N cells are there, it is NR. In our example 4 cells are there, so it is 4R. NR plus capital R. Capital R is the external resistance. So now we can get the current in the circuit using Ohm's law. As per Ohm's law, V is equal to IR. After rearranging, I is equal to V by R. So for getting the current, potential difference is to be divided by resistance. Now EMF is N times psi. So instead of V, we can write N times psi. Then resistance, total resistance in the circuit is NR plus capital R. So this is the current in the circuit. Now there are 2 cases. Case A, when internal resistance of the cell is very much lesser than the external resistance. When small r is very much lesser than capital R, this NR can be neglected because it is lesser than capital R, very much lesser, and R is lesser than capital R, NR is going to be very much lesser than capital R. So this NR can be neglected. So current in the circuit can be represented by I is equal to this NR can be neglected, so N psi by R. This psi by R is I1, that is the current due to a single cell. So total current in the circuit is N times the current due to a single cell. This I1 is current due to a single cell. Now case B, internal resistance is very much greater than the external resistance. Now this R is to be, capital R is to be neglected. Then R and N will get cancelled. So psi by R, this N will get cancelled. This R is to be neglected. Then N psi by NR, then N will get cancelled. So current in the circuit is psi by R. So current in the circuit is the current due to single cell. Then if cells are connected in series, it will be advantageous only when internal resistance is very much lesser than R. Then only total current will be N times I1. Otherwise current in the circuit will be equal to the current due to a single cell when internal resistance is very much greater than R, capital R. In this circuit, let the external resistance be 10 ohm and EMF of each cell is 9 volt. Internal resistance of each cell is 0.1 ohm. Now, equivalent EMF is n times the EMF of each cell. So now here 4 cells are there, so this n is 4, then EMF of each cell is 9, so EMF across this battery, that is equivalent EMF is 36 volt. Equivalent internal resistance is n times R, where n is 4, then internal resistance of each cell is 0.1. So total internal resistance, equivalent internal resistance is 0.4 ohm. Then total current I is equal to n times psi. So this is the equivalent EMF, then divided by the total resistance. Capital R is the external resistance and equivalent internal resistance is n times small r. N is 4, 4 into 9 divided by external resistance is 10, then n 4, then internal resistance of each cell is 0.1, so 4 into 9 36, 4 into 0.1 0.4, so it is 10.4, 36 divided by 10.4 is 3.46 ampere. Then potential drop across the external resistance. V is equal to IR. I is 3.46 into external resistance is 10. So when you multiply by 10, it will be 34.6. So you can see equivalent EMF is 36, but the potential drop across this external resistance is 34.6. From this 36, you subtract 34.6. So you can see 1.4 volt. 1.4 volt is dropped in the internal resistance. Now potential difference across each cell is V by N. V is 34.6. Then across this 34.6, then 4 cells are there, so you divide by 4, so you will get 8.65 volt. So potential difference across each cell is 8.65 volt. Thank you for watching.